very last property of logarithms is the power property of logarithms, and it relates to this. Let's say we've got x squared raised to the third power. So you got a power raised to a power, and to simplify it, you multiply the exponents and end up with x to the sixth. So this power is pretty much the same thing. If you're taking the log in base 4 of 3 squared, so it's a power, you can rewrite that, you can manipulate it a little bit, and what you do with the exponent, that 2, if you can see what it equals on the right, you bring it out to the left and you multiply, so it's 2 times the log in base 4 of 3. So let's explain it with the general case. The general case is going to be log. If you have the log of any base, so let's put a variable a, of a power, so the basis of this power is b and the exponents c. So the log in base a of b to the c power is equal to, if you were to manipulate it, you would bring that exponent c out front and multiply it by the log in that base a of b. So let's do the 2 practice problems. Let's look at the first one. 4 times the log in base 2 of x plus log in base 2 of 5 equals log in base 2 of 405. What's nice is they're all log in base 2. So let's see if we can use this new property, this power property, and hopefully you see right here you can play around with it a little bit. And I'm going to use the converse. So what they've given me looks something like this. So I'm going to work backwards and make it look like you're taking the log of a power. And what you do with the 4 is, that's the exponent. So log in base 2 of x to the 4th plus log in base 2 of 5 equals log in base 2 of 405. Now if you stare at that, we're going to use another property. So this ties in 2 properties. And when you are adding 2 logs, you can rewrite these 2 logs and express them as 1 log. And that 1 log is going to be log in base 2 of x to the 4th times 5. So now we've got 1 log on the left, 1 log on the right. So we can our logs are going to undo themselves, and what you really have, let me erase some of this, you've just got 5 times x to the 4th equals 405. Now let's just solve for x. So let's get rid of the 5. Let's divide both sides by 5. Divide this by 5. Divide this by 5. Got x to the 4th equals 81. And kind of a cool trick right here. If you notice, 81 is a perfect square. If we do the square root of 81 and square root of x to the 4th, we're going to have x squared equals 9. And if we do it again, square root, the only thing you need to remember is there's going to be 2 roots. There's going to be a plus or minus 3. So our answer is going to be x equals 3 or a negative 3. And maybe we're going to be a little bit suspicious of the negative 3. So let's take that negative 3 and let's sub it back into the original problem and see if it's going to work for us. So I'm going to sub it right in here for x, and right off the bat I know it's a no solution, because you can never have 4 times the log in base 2 of a negative 3. This right here is a contradictory. Can't have the log of a negative number. That's the very first property that we learned. So the answer is just 3. Now on this one's totally different. Let's solve for x. First move, let's add 6 to both sides. So you're going to have 3 times the log in base 5 of x squared plus 9, and that's equal to 6. Now let's get rid of the 3. There's kind of two routes you can go. If you take the 3 and rewrite it using this power and put it as an exponent, that will work, but it's going to be super tedious because you're going to have x squared plus 9 raised to the third power, so that means you're going to have that quantity, x squared plus 9, times itself 3 times. And you're going to have to do a lot of distributive property, and it's going to get kind of funky pretty quick. So instead of going that route, let's just use algebra, and let's get rid of that 3. The problem is 3 times this whole chunk. This whole chunk is just one term. It's just one piece. So if I divide this side by 3 and divide this side by 3, 3 divided by 3 is 1, 6 divided by 3 is 2. So now I got this. The log in base 5 of x squared plus 9 is equal to 2. And now that I can't, there's not a log in base 5 on the right, so I can't undo my logs. So when you come to a problem like this, probably the best route is to rewrite it as a power. So right now it's in logarithmic form. Let's express it in exponential form. So I need a base, an exponent, and what it equals. The base is easy, that's 5. The exponent is this, 2, and what it equals is x squared plus 9. So now I'm getting somewhere. Now it's starting to look a little more familiar. So let's do 5 squared, that's 25, equals x squared plus 9. And let's just solve for x. So it's minus 9 minus 9, 16 equals x squared. Do the square root of both sides. X is going to equal, we're in the same problem, I need both roots, the 4 and the negative 4. And then maybe let's be a little suspicious of that negative 4. Let's plug negative 4 in and see if it's going to work. So when we plug negative 4 in, negative 4 squared, negative 4 times a negative 4, that's positive 16. Positive 16 plus 9 is 25, so we're safe. So this one is actually a case where you do have two answers, and they're both legitimate. 4 and a negative 4. Okay, the last part. If you understand these, you can do the first 10 on your worksheet. And what we've got is they're giving you a decimal value for this. The log in base 10 of 5. And the decimal value is 0.6990. And the log in base 10 of 7 is 0.8451. So you're going to use those two decimals to solve 1 through 4. Now, you got to think in terms of only a 5 and a 7. And we've got to use our properties of logarithms. Number 1, I'm taking the log in base 10 of 35. So somehow I got to be creative and use the log of base 5 and the log of base 7, or separately or combine them together with plus minus times divide to get a 35. And I think I can do it if I rewrite 35 as the log in base 10 of 5 times 7. 5 times 7 is 35. So far that's a legal move. Now I'm going to use my product property of logarithms, and I'm going to express this as log in base 10 of 5 plus log in base 10 of 7. Now I'm home free. I'm going to replace log in base 10 of 5 with that decimal, 0.6990, and log in base 10 of 0, or 7, I'm going to replace with 0.8451, and I'm just going to add those two decimals up. And that's your answer. So let's look at number 2. Log in base 10 of 25. How can I use a 5 and a 7 to get 25? Or maybe just one of them. So, if you can see 25, there's two ways to look at it. Hopefully you got one of the two. There's either log in base 10 of 5 times 5, or log in base 10 of 5 squared. Either one of those is going to work, and I'm going to do the one on the right, the log in base 10 of 5 squared. So the property that you just barely learned, let's manipulate that a little bit, and let's rewrite this as 2 times the log in base 10 of 5. Then I'm going to replace this guy with that decimal and simply times it by 2, and you're done. So your answer is going to be some decimal. Okay, number 3, log in base 10 of 7 divided by 5. That's kind of a freebie because they're using the 7 and the 5. All you do is use your quotient property, and you're going to go log in base 10 of 7, subtract log in base 10 of 5. So then you just substitute those decimals, subtract, and you have got it. So this should be it. You should be able to do the entire worksheet of 10.3, and we'll get ready to move on.